So I'm going to try something out with recording solutions to the certain problems that we're doing, especially for like quiz reviews and stuff like that. If it turns out bad, oh well. So we're doing partial differentiation. Got a function f(x) equals x squared y cubed plus x to the fourth y plus x e to the y. The first thing we want to do is we want to find the partial with respect to x. And so what I'm going to do here is I'm going to do the method of pulling constant terms to the front of the derivative, taking the derivative, and then putting the constant term back in. So, all right, the partial is f with respect to x. We want to do, let's see, that's the partial with respect to x of this first term, plus the partial with respect to x of the second term, plus the partial with respect to x of this third term. Cool, because remember that when we take a derivative of a function, we can do all the terms individually as derivatives. Cool. Now, we're differentiating with respect to x, so what I want to do is I want to pull non-x terms out. So we've got like a y cubed here, we've got a y here, we've got an e to the y here. So I'm going to pull those out in the individual derivatives. So like, for example, here we do y cubed, and then we have the partial with respect to x is x squared. Then here, we've got the y that's going to come out. So y partial with respect to x is x to the fourth. And then here, this e to the y term is our constant e term. So e to the y partial with respect to x of x. Cool. And then these individual parts are pretty easy. The derivative with respect to x of x squared is just 2x. So we've got y cubed times our x squared, the derivative of that is 2x. I'll write my 2's differently because that looks like the partial symbol. 2x. Here, the y stays out front, and we've got the derivative of x to the fourth with respect to x. That's going to be times 4x to the third. And then here, that e to the y stays out front. The partial with respect to x of x is just 1. So we get e to the y. And then we're going to rewrite this. How we typically rewrite it is we do powers of the first variable, powers of the second variable in that order. So here we have 2x and then y, our second variable. Here we have 4x cubed y. And we also pull our coefficients out to the front. So like I pulled the 2 out front here, I pulled the 4 out front there. And this over here is just going to be e to the y. So that is our solution. This is the partial with respect to x of our function up here. All right. Now we're doing the partial with respect to y of this. So what we're going to do is we're going to pull all non-y terms out to the front. So for example, the first time we're doing x squared partial with respect to y of y cubed. Plus this one, the y term is going to come out. So get y partial with respect, or not y, the x term, my apologies. That's x to the fourth comes in the front of that partial with respect to y of y. And over here, the x term is our constant term. So you get x partial with respect to y of e to the y. Cool. And again, these are pretty simple to take on their own. You get x squared partial of y cubed with respect to y is 3y squared. And you got x to the fourth partial with respect to y of y is just 1. And we've got x times partial with respect to y of e to the y is e to the y. Cool. And then I'm going to do the rewriting. Here I'm going to bring the coefficient out front, so 3 in my first variable, second variable. So x squared y squared plus anything times 1 is just that individual item. So this is x to the fourth. And then we've got x e to the y. I'm going to leave it as that. And that is our answer right there. All right, now we want to take the second partial with respect to x. So we're recalling what our partial with respect to x is right here. Now we're taking the partial with respect to x of that. So what I'm going to do is I'm going to take the partial of each individual term. Cool. So now what do we have? We have the partial of the first term with respect to x, partial of the second term with respect to x, partial of the third term with respect to x. And now what I want to do is I want to bring the constant terms out in front of those. So here our y cubed is a constant term, but technically the whole of 2y cubed is a constant term. But it doesn't matter, it would work the same way. I'm just going to I'll pull the whole 2y cubed out. So you get 2y cubed partial with respect to x of x, plus, I'm going to bring the 4y out front, and then we're left with the partial with respect to x of x cubed. And then here, there is no non-x term, so it stays the same. Or there's only non-x terms, I should say. Cool. Now we can evaluate these. Go straight forward. So we're left with our constant term. The derivative of x with respect to x is just 1. Then we've got our constant term for y. The derivative with respect to x of x cubed is 3x squared. And then the derivative with respect to x of e to the y is just 0. What we could have done here is we could have pulled the e to the y out front, and then this would have just been 1, but the derivative of 1 is also 0, so it wouldn't have mattered. And then I'm going to rewrite this. So here, 2y cubed times 1 is just 2y cubed. Here, I've got 4y and then 3x squared. I'm going to bring the 3 and the 4 together to get 12. And then first variable are x squared, and then our second variable y, and then 0. So we're just going to leave it as this. So we get 2y cubed plus 12x squared y. All right. Now we want to find the partial with respect to xy. So what we're going to do is we're going to take our partial with respect to x, and we're going to find the derivative of that with respect to y, the partial with respect to y. So what I've done here is I've put the partial with respect to y in front of our individual terms. Now what we can do is we can take out the constant term. So that would be the x terms here because we're with respect to y. So here the 2x would come out front of our partial with respect to y. Now we're left with y cubed here. Here the 4x cubed would come out front. And then partial with respect to y of just y. And then there is no x terms here, so we just have partial with respect to y of e to the y. And now we can evaluate these individually. So we got the 2x staying out front. Partial with respect to y of y is 3y squared. The 4x cubed stays out front here. We're left with the partial with respect to y of y, which is just 1. Times 1. Plus, and then the partial with respect to y of e to the y is just e to the y. Right, because we would bring the derivative of y down. The derivative of y is just 1, so we're just left with e to the y. And then I'm going to combine these. So I've got the 2 and the 3 gives me a 6 multiplied together. And then we get xy squared. Here, 4x cubed times 1 is just 4x cubed. And then just e to the y. And so that's our final answer. We get that the partial with respect to x and y is 6xy squared plus 4x cubed plus e to the y. All right, and then our last partial derivative, then we found all 5 partial derivatives up to second order. We're doing the second partial of y, and so that's the partial of the partial of y with respect to y. So we get partial with respect to y of fy, which we've already found. So what I've written out here is I've written out the partial with respect to y of each individual term. Now we're going to go through, pull out the constant terms, and evaluate them. Constant terms here are going to be an x because we're with respect to y. So for example, this first one, we get 3x squared partial with respect to y of just y squared. This next one, there are no y terms. All of it's constant. I'm just going to leave it as is, though. Partial with respect to y of x to the 4th. And then here, our x by itself is the constant term. with x partial with respect to y equal to y. Then we can evaluate the individual partials. We get the 3x squared stays out front. And then partial with respect to y of y squared is 2y. Partial with respect to y of x to the fourth is 0, because there is no y term here. And we get x times partial with respect to y of e to the y is still e to the y. Rewrite this first term. We get the 3 times 2 is 6. The x squared of y. Don't have to worry about that 0. And then we get x e to the y. Cool. And that is the answer of the second partial with respect to y. And that is all of our partials. I'll put them back on the board so we can look over them. All right. So after it's all said and done, we have our 5 partial derivatives. The partial with respect to x, partial with respect to y, second partial with respect to x, second one partial with respect to x and y, second partial with respect to y. We'll see here in a couple of days what we're going to do with these. What we're going to do is we're going to create systems to find the minimum, maximum, critical points, saddle points, all of that, of surfaces bounded by these specific equations. So